Now let's take a look at the RBD Dynamics, the rigid body simulation. Let's see how we can create that inside of in Houdini. In here, let's create a geometry node, and in here, let's create a geometry that we want to simulate. And I'm going to just create a rubber toy geometry in here, and here we have it. And now let's make this a RBD object and let's simulate this. And first I'm going to just move this up the translation so that we have some distance between the ground. And now let's create a top net, our dynamic network, because rigid bodies and a dynamic simulation, which mean we must be inside of the top net. And now let's dive inside the top net. First we need the object, and because we are working with rigid body, we have the RBD object node, and here we have it. Let's add an RBD object, and we also need the rigid body solver. So in here, let's type the rigid body solver, and here we have it. And the first input of the solvers are for the object, so let's connect this, and I'm going to connect this onto the out. And right now, here as you can see, we have the sphere, and that is because onto the RBD object, if I enable its parameter, and here as you can see, we have a default geometry onto the SOP path. And right now we are not importing our own rubber toy geometry. So in here onto the SOP path, let's import our rubber toy geometry. In here, I'm going to just select my geometry and hit accept. And there you go. Here we have our geometry imported into tops. And now with that, this simulation network is done. We have the solver and we have the object. And now if I were to hit play, and here you can see nothing is happening. And as you know, we do not have any forces in here. So let's create a gravity force. I'm going to type a gravity, and here we have the gravity force. And we just need to connect this in here. And now if I were to hit play, and here you can see our object is falling due to the gravity. And I'm going to enable this real-time playback. And now let's add a ground plane in here for the collision. Right now it's going through because there is nothing to collide with. So in here I'm going to create a ground plane. Let's type this and let's merge this with our simulation. Connect this into the merge node, and we need to organize this because order of the merge matter. So let's click on it, and now we have onto the left side. And now this ground plane should work as a collider. Now let's hit play, and here as you can see, we have our very first RBD simulation. Right now, here as you can see, we are using this RBD object, and it is a computationally heavy to calculate this rigid body simulation, because we are right now simulating all of these points. I can see my simulation geometry. If I go into the RBD object, let's enable the parameter. Let's go to the collision tab. We can see what this solver is actually using for the collision. I can enable the collision guide. Down here onto the collision, we have the RBD solver, and right now we are using the volume based collision. So let's enable this collision guide, and here it is visualized in this blue. And right now our collision geometry is cutting off because of this simulation geometry. So I'm going to just in here click on this display geometry to uncheck this option, and there we have our collision geometry. So that is basically the geometry that we are simulating. And right now here as you can see, we have this volume based collision, and I can increase the resolution, and same thing, we have this uniform or this voxel size because we are working with volume. And now let's increase this, and here as you can see, as I am continue to increase this, right now I think I accidentally create a lot more voxels, and that is why my Houdini session has been freezed. So I'm going to just lower this value down to maybe 100 to a manageable voxel size. And right now here as you can see, we have a very high res mesh. And if I were to hit play, and here as you can see, our simulation is very slow because we are simulating all of these points. I'm going to just default out the settings. Just press and hold the control key and middle mouse button to default it out. So let's make this onto the default. Let me also disable the collision guide and let's enable the display geometry. Let's go back, and if I were to middle mouse button onto our this .NET, and here as you can see right now we are using the 2 megabyte of our system RAM just to simulate our this single object, and it will get slow if we are going to create multiple of these objects. And I can create in here by adding a copy and transform node, because as you know, when we are working with RBD simulation, we might be creating the destruction simulation, and in the destruction we have lot more smaller pieces of geometry. We have chunks of different pieces of fractured geometry, rubbles. It's not going to be just a single piece of object like this. We will have many pieces that we want to simulate. I'm going to just create a copy to transform, and let's translate this a bit up, and maybe let's add a Z onto the translation. And in here I'm going to just create multiple copies. And now if I were to import this in here, right now here as you can see this connection does not matter, because inside of the .NET we are actually defining our saw path in here, which means that if you connect this or not, it will still going to be work, because we are not using these inputs, we are not referencing them. Onto the .NET, let's import our this copy node, and onto the RBD object, let me pick my this copy, and here we have the copy one, and hit accept. And here we have all of our geometry imported. And now if I were to hit play, and here as you can see, now the solver sees all of the geometry as we have this a1 geometry. So the RBD object, this rigid body solver, does not know that we have multiple geometries that we want to simulate, and which means we need to actually extract all of our geometry. Copy and transform node, we have some attributes. So let's go in here, we can enable the copy number attribute, and let's enable this, and that will create a copy num primitive attribute. And if I were to middle mouse button, and here as you can see we have the copy num, and it will just store the number of copies. And for the very first copy it will just store the copy number, which will be the 0 1 2 and 3 4. It will start with the 0. Right now we are using the 5 copies, so we will get the number at these from 0 to 4. I can confirm. Let's click on this copy and transform, go into the geometry spreadsheet, and it is a primitive attribute. So let's go into the primitive, and here we have the copy num. Let's click on it, and maybe click on this again to organize this, change this order ascending. Here you can see we have the copy number 4, and we are starting with 0. It will just storing this copy num. And now I can just make a selection based on this attribute, because let me enable my selection tool. Right now my selection constraint has been enabled. As you know, if I were to change this to 3D connected geometry, we have this rubber toy geometry that is actually made out of multiple pieces of connected geometry. We have that is connected, and we have multiple pieces. So this connectivity will not work, and instead I'm going to use my own attribute. So in here, just click on this name attribute. This selection is looking for the attribute that is called name. We do not have name attribute, but I want to select based on my copy num attribute. And to actually change this, let's click on this gear button. We can say attributes, and here we have the list of attributes that are present onto the geometry, and I'm going to change this to copy num. It will take a look at the unique values, and right now here it finds that all of the geometries has unique. We have 0 1 2 3 and 4. And now I can just select my this first copy, and in here I'm going to just blast this out. Let's type blast and hit enter, and it will just blast this copy only, and we have all of our geometry. What I can do, I can just isolate this. So let's go into the blast node, and right now we are using the copy num 0, and let's click on this delete non-selected. That way we can just isolate this copy, and I'm going to just duplicate this blast node, and for this one I'm going to just change this value. And here as you can see we are using the copy num for the primitive deletion, and in here I'm going to just change this to 1, and that way we can isolate this. And I'm going to duplicate this again, and I'm going to change this to 2. Let's duplicate this again, and I'm going to change this 3. And we have these 4 copies. Let's go into the .NET. To actually import all of them, we need to create separate RBD objects. Let's in here onto the saw path. Let me pick the copy num 0, that is our first RBD object, and I'm going to just duplicate this RBD object. I'm going to select my second copy, duplicate this again. I'm going to pick our third copy, duplicate this one more time, and now we have the last one. And now to actually add this into our simulation, let's add a merge node, and let's merge all of our objects and use them into the solver. And I think we are importing this multiple times. If I were to delete this, and I think that is plus 2 and that is plus 3. So why it was looking the same? Let me check first. Let me connect this in here, and here we have it. Let me connect this in between. Okay, I think it was just showing me that, but it's fine. Now let's hit play, and here you will see now we have multiple objects. Here you can see it's actually slow. It's actually also slow to import because we need to separate all of our objects if we want to simulate them separately, and it is also computationally slow as well. And right now we are only working with 4 copies. We are only just creating RBD these 4 objects. If I were to go back and press and hold the middle mouse button, and here you can see only these 4 objects, these 4 copies, they are taking 14 megabyte of system RAM. Well, right now it's not quite a lot, but as the number of copies will get increased, this will going to be increased exponentially also. So to fix this, there is a better way to simulating the RBD object, and that is the RBD fact object. In here, to create the RBD fact object, first we need to pack our geometry. Right now, here you can see, if I were to middle mouse button, we are working with regular geometry, which means we have these points. If I were to enable my selection, let's disable this selection constraint. Here you can see we have all of the individual polygons, and we also have individual points. We are working with actual geometry, all of these points. And what we can do, we can pack our geometry into single point. So in here, I can do this by adding a pack node. Let's add this in here. Let's connect this, and as you know that pack node will pack our geometry into single point. If I were to middle mouse button, as you can see, we are working with 1 point only, and Houdini is drawing our geometry. Houdini knows how to draw the actual geometry, but geometry itself is not there. We only have 1 point. If I were to try to select, and here you can see I'm only able to select 1 point because we only have 1 point, that is storing the location that where this 3D object is placed in the 3D space, and it is also storing the orientation, how the object is oriented in the 3D space, which means that we are only going to simulate 1 point, and it will be very fast to simulate because these are the rigid bodies. They do not deform. We do not need the actual deformation onto our mesh. We are actually going to be simulating its position and orientation, because in the rigid body dynamics only the position and orientations matter, right? Let's see how we can use the pack primitive to simulate. And I'm going to this time connect this onto my first input. Let's dive inside the .NET, and let's hit rewind to clear out, to go back at the very first frame. I'm not going to use the RBD object. I'm going to just remove this wire, and maybe let's select all of them and let's put them aside. I'm going to just remove the wire in here. And to actually import this our packed geometry, we also have a node called RBD packed object. If you type RBD packed object, and here we have it. Let's add this, and that is also an object. We need to connect this onto this object slot and onto the RBD packed object. In here we can specify our geometry source and we can pick our saw path, or in here we also have the option to reference our these inputs. So I'm going to use the first context geometry so that I can use these inputs for referencing. And now if I were to hit play, and here as you can see, we still have our this RBD simulation, and now it is a very fast simulation because we are not simulating all of these points. And it is also creating a collision mesh because we need the mesh for collision information, and we can visualize our simulation geometry like we have visualized onto the RBD object. We also have the visualization onto the RBD packed object as well. So let's enable its parameter, and we can view this into the bullet data because we are right now using the bullet solver, and here you can see the solver engine is bullet. Bullet solver will use the packed primitive to simulate your geometry. I can enable the show guide geometry, and here you can see that is the geometry that this solver is actually simulating. And if I were to zoom in, and here you can see it is a basic representation of our geometry. It's wrapping convex hull of geometry to represent our this original geometry. And I can change this collision shape. Right now here as you can see we are using the convex hull, and we can change this to concave. And right now I cannot see this. Maybe let's go into the display geometry, onto the simulation geometry. Let's uncheck this to actually visualize. And now we are going to simulate our this concave. Now it will be expensive to simulate, but we will get better collision. And if I were to hit play, and it will be slow because you know that now we are working with a lot more points. Let's change this to convex hull, and we also have some other option. We can change this to box. It will just orient a box around it, and it will simulate only box, and it will be very fast. And I'm going to use the convex hull, and you should always keep this to convex hull. I'm going to uncheck this guide geometry and enable display geometry. Now I can import multiple of our these object. Let's go back onto our this copy and transform. Let's maybe add this in here, and I'm going to, if you were just to connect this onto the pack. Right now if I were to middle mouse button, and here you can see this pack object is now packing all of our geometry because now this pack node thinks that all of this geometry is a one piece of geometry. So into the pack, now all of this is a one single piece of geometry. And if I were to go into the .NET and simulate, and here as you can see we are simulating this as if we have a one piece of geometry. And to fix this we need to create a individual packed primitive. And because we are working with copy node, I can go into the copy and transform, and in here we have the option to enable pack and instance. And let's enable this, and what it will do, it will just pack all of our copies and then it will instance them. And now if I were to middle mouse button, and here as you can see now we are creating 5 primitive. We are working with 5 copies, and now the solver should work fine because now it knows that there is a 5 separate pieces of geometry because we have 5 separate packed primitive. And now if we go into the .NET, now it will create convex hull for all of these objects separately, and I can confirm. Let's go into the RBD packed object, and let's enable the show guide geometry. And here as you can see now we have convex hull for each of them separately. And now if I were to hit simulate, and here as you can see our this simulation is working, and now we are only using this single object to import all of them. Before that we need to create the RBD object separately for each of the object. Let's go back. I can just keep adding more and more of our geometry. Let's say I'm going to create a grid node in here, and I'm going to just let me move this up, and I'm going to create a copy transform node, copy and transform, and sorry, not copy and transform, copy to points, because I want to copy this geometry onto my grid points. Sorry, why I'm keep using this copy transform. Copy to points, copy to points. Let's add this, and that is the geometry, and that is our points. And let's view this copy to points, and right now our this copy to points is not packing our geometry. Here as you can see, we can pack this. Let's go into the copy to point and enable pack and instance. And now if I were to middle mouse button, now we are creating 100 packed fragments. And right now the alignment is not correct, but that's fine. Let's go into the grid, and I'm going to change the center to move this up so that we have some distance between the ground. I'm going to just first, I think they are now intersecting. We need to go into the grid, and let's increase the overall size until they are not intersecting, and I think that value is fine. Let's connect this onto our this .NET, and let's visualize this. And here as you can see, we are simulating all of our object, and right now our simulation is very fast, it's very responsive. I can keep adding multiple copies, and after that maybe let's connect also our this copy and transform node. I'm going to not use the backend instance because we are already working with packed geometries. So let's go into the copy, and it will just create these packed primitives, and right now we have a lot more of our geometries. And now let's connect this in here, and let's simulate. And here as you can see, we are simulating just fine. We are working with lots of objects, and if you take a look, it's very responsive. If I were to press and hold the middle mouse button, and here as you can see, even though we are working with lot more of our packed primitive, we are only still using 400 kilobytes of system RAM. So these packed primitives, these RBD packed objects, are very efficient to simulate. We are going to be using these packed geometry in the RBD simulation. We also have the RBD solver available onto the SOP, and if you type the RBD solver, and here we have the bullet solver, RBD bullet solver, and let's add this, and that is an same .NET with the basic node that we have just created, or this rigid body solver, gravity, and all of these things pre-attached, which mean we can just connect this in here onto our this bullet solver and hit play, and all of our simulation will work fine. And I'm going to just not create that many copies, so let's lower down the number of copies, and here you will see. And I can go into the bullet solver, and we have some parameter. I can go into the collision tab, and in here we also have the option to add the ground plane. So let's add the ground plane, and let's hit play. And here you can see we have our this simulation .NET pre-configured for us, which means we do not have to every time create this .NET ourselves. So let's take a look at this RBD bullet solver in the next lesson.